Welcome back. We're at episode 11 in our tantalizing series about programming for the NES. The last time we were here on Thursday of last week, we had gotten the start of our tool that we're building for our game created. So we had begun work on a immediate mode interface that we were going to use to deal with our assets and maps and stuff like that. And then obviously we have our game, which doesn't do a whole lot right now, but we're at a good point where we're able to load things. And of course I don't have my controller hooked up, but load the ship and fire bullets, collide with enemies and destroy them. And at this point, I think we want to have a tool that allows us to deal with managing our assets, drawing our bounding boxes, stuff like that. One thing I do want to bring up is on the YouTube recording, someone named Carol brought up a good point, which is that in the vblank code here, I am loading A and storing it in 7FF for my debugging code, where I'm counting the cycles in the vblank, or in the NMI, I should say. And unfortunately, I do that before I push A, so that would create problems where A would sometimes have the value 2 in it and shouldn't, as he pointed out. So I will move this to here so that we've pushed A onto the stack before we go to change it and store it in 7FF, and then the rest is fine. So thanks, Carol, for pointing that out. That probably created a few weird issues that we were seeing sporadically as we were working on things. And I wish I had a controller here. Just give me a second. I'll be right back and I'll get my controller. Yeah, all right. Sorry about that. So now that should be working. Okay, so there's our lovely NES code running. All right. So let's go back to the tool, and where we left it off last time was that it was able to draw buttons that were discrete and did what you kind of expected. It highlights them and allows you to click on them, which is good. That's where we wanted to get to last time. In thinking about it since Thursday, I kind of realized that I want to maybe switch this back to a C++ file instead of just being a C file. The reason being because I want to make use of a couple of things from C++, like constants and enumerations potentially, which in C you can do, but they're just pound defines. So I'm going to change this now. The reason we had done this is because we ran into a problem with a couple of things. One was that we were getting name mangling from the C++ code. The other was that we really didn't need to be using the anything in C++ at the time, so I didn't really think we had any reason to keep it around. All right, so what is it because of the control data structure? Let's see. What's the problem? Button data is not a member of control node T. Control node. Just make this an anonymous union, and there we go. So that's that. Well, it's interesting that it compiled without any errors this time. I wonder if the error that I was seeing last time had nothing to do with the name mangling, but it was instead related to the way I typedef this function pointer stuff. Does it work still? Still works. Okay, well that's good. Okay. So we're back to that. And then, like I said, I wanted to be able to use some constants. So for example, I wanted to be able to make these color constants. And then let's see where are my other ones. So this can be dark gray. And this is light gray. And this is black. And this was light gray. This was white, and that's the thing, right? Like, is we're just able to just use these constants. Instead of, I mean, we could have done pound define for that too, but that's just expanding out the colors, the definitions of the colors into the C code, which I didn't really want. Just a little thing, but I don't know. Felt like we needed it. Oh, to your RGB. I messed up that color for the background, but it doesn't matter. It's fine. It's just wanted to get that all turned into constants. And then for the controller types, same thing. Oh yeah. Well, I guess I can start using put that in a namespace to differentiate it. Of course, now that's going to break some other stuff, but that's all right. So this is GUI. That's that, and that's good. Okay. So we've got this. So where we left off last time was that each time we rendered a child, we were freeing it because essentially we were rebuilding the node structure, the tree structure every time. So if we just go back to what we were talking about. So the way that it was working before is that, you know, you had the background, which was the root node, and then you had essentially an n-way tree of controls that are subcomponents of the background, or, you know, layered on top, and, you know, those can have their own components within. And then in order to render the UI, we were recursively traversing this tree and rendering down the components onto the screen. And so this would recursively traverse to the lastmost child and then call the renderer, and the renderer would then draw the control, and it would just kind of layer on top, one after another. Although one thing to point out is that we're not drawing the child at the end of recursing down and then recursively drawing, because that would draw in the wrong direction and we get the background covering everything. What we do is we draw the node we're on, and then we recurse down to the next node, and then that draws itself, and then it recurses down to the next node, and then down to the next node, and all of that is so that we get the right kind of drawing with the components overlapping their parents. And then the actual rendering is handled by a function that gets put into the control node for the component for the button itself that we're dealing with. And right now it's using just an X and a Y for the node. If I remember right, I wanted it to be relative to the parent, not absolute to the screen. Well, you know, we'll deal with that in a minute. More importantly, right now, what I want to deal with is the fact that we're freeing the child every time, and the fact that we have to recreate it every time. So what I'm thinking we'll do is we'll change this so that when you create a component in the user interface, we'll assign it an ID, and then when we process the tree the next time, where we start building it again, we'll mark the nodes as potentially invalid, and we'll delete nodes that are not re-added as we traverse for rendering. So basically what I'm saying is, the first time through, or rather as you add components to the tree, they'll be marked as active, you know, so they'll have a 1, let's just say, right? The next time through, before we start, we traverse any nodes that are in this tree, which is just a simple recursive call, set all of those nodes to 0, and then from there, when we go to add another component to the tree, well, the root, I guess, never becomes 0 because we always want the root to be rendered as the background, right? So when we go to add a new control, let's say this was a button with a specific ID. Let's say this is button ID 7, right? If we go to add this again, then this 0 becomes a 1. And then when we're done, what we'll do is we'll go call the render code, and it'll look at the nodes that are here, and let's say it gets to a node that's 0 here, that will invalidate the rest of the subtree, right? And it'll just stop, and then it won't render any of the subcontrols there. Same thing with any of these other nodes, so that unless we're explicitly re-adding them by a call to add those controls, they won't get rendered and they'll get pruned from the tree, but we don't have to go through the process of removing them. If we're excuse me, looking at a part of the screen that's currently active and should continue to be added to the screen as we work with the tool. So, for example, if we're working in the screen and a dialog pops up, right, that's asking us something, we have an OK cancel, right? When you click on, let's say, the OK, at that point, that part of the interface tree will not get updated, and so that whole part that has the dialogue and the buttons and the text and everything in it will not get rendered, and therefore will effectively look at like it disappeared, like the dialogue disappeared, right? I think that'll work. I think that makes sense as a basic way to handle this. And then it has the added benefit of not having to prune the tree every time. You prune it as needed, and you can prune it in sort of chunks, because if a parent node is inactive, then the children should be considered inactive too, and so there's no point in even bothering to look at them. You just want to clean them up. All right, so let's do that. Hey, we can use booleans now. Okay. So what I'm going to do is I'm going to add something called just sort of generic begin. And I don't know that we'll need end, but we might. So what I want to do, let me think about this. So what I want to do is I want to move this into the GUI namespace also, since it's related. All right, so then what I want to do is I want to have begin. I guess it should take the does it make sense to have it take the tree? I know for render we're having it take the screen and the tree. The button doesn't take it. It seems kind of inconsistent. I'm going to say it probably doesn't need to take this. Probably we can deal with that separately. Well, let me do this. What was it called? Oh, because it's part of main. How is button doing it? Oh, because it's returning the node. Yeah, but wait a minute. Oh, right. Okay, so I forgot we had this concept of a current context that it was adding it to. Oh, okay, so that actually works. That works for a couple of things. So let's do this. So we do need to pass our tree here because I want this to reset the context every time. It's just current context. Oh, okay. Although I have tree root. Yeah. I'm okay with that. We'll leave that for now. You know, all of this stuff is fluid, and as we go and we work on it, it's going to be changing. So nothing is set in stone here. I'm just trying to make something that sort of makes sense for what we're doing now, and then we can circle back and clean it up. since we don't really know 100% of the design right now anyway, trying to make too much of it in advance will potentially just clutter things up. Alright, so we've got our node. I don't know that we need to do anything in end, like I said, but we'll leave it for now. So that's the current context that it gets initialized, that it's doing. Okay, and then we can do a simple right? Yeah. Okay. Are these still pointers? They are still pointers. Okay. Current control, current context. Okay. So I guess I shouldn't make this be the recursive call. I don't like that name. Reset tree. So all this is going to do is make this active, and then for each of the children call itself with first equals null, so that it will set the active correctly. Okay, so I is less than node child capacity. If node children, spell that right, I, so if that's not null, node false, node child. All right, so that's that. So we know, so now we're going to recursively traverse the tree to set the active flag to true or false. We're going to do that every time. The only other thing we need to do is we need to add some sort of identifier where when we add our component, we have an ID, and we just need to see if that ID exists in the tree first. Call this find set active ID. So basically, find set active will return true if it finds it and sets it active. Otherwise, it'll return false. We don't want to. Okay, so what I really want to do is I want to say if we didn't find it and set it active, we're going to actually create it here and add it, and then. But we need the node. All right, new plan. So we're going to do this. We're going to return it when we find it, if we find it. So if not node, then we will create it, and we button width and stuff to be initialized properly, right? So that can be moved out here. So that'll get set there. Otherwise, we want a button width is equal to node button data. I'll save it. We can save that in the structure here, so we don't have to recalculate it every time. So we've got that, and let's actually save that now. Oh, we don't actually have a node yet. Why is it passing the width and the height? Right. Oh, I forgot we added width and height to it. Okay, so we don't need a separate... well, you know what we probably want... We want the text width and height because that's going to affect the... Right now we're recalculating the text width and height. We probably don't need to be doing that. I don't know how expensive that call is. It probably isn't super cheap to do. I don't know. We can probably look and find out, but it's not that big a deal to store it. So we'll change this to text width and text height. So the button width and the button height go into there. So that now has the width and height there, and then we can say node button data text height is equal to height. Oops, text width. So now we have that, and then this is not necessary because that's being stored in the... Oh, wait a minute. Yeah, we do want to store that. So that's just the width and the height. All right, so now we have that. And then in our render button call, we don't need to recalculate the text width and height anymore. It's just node button data text width. Height. And then we need to obviously define this, find set active, unsigned int ID. Let's actually I just want to see if there are any other problems with the changes I made. Const car pointer. Oh, right. So we've got to give it an ID. So just for now, we'll say these are buttons 1 and 2. What we'll do is we'll define some constants as we actually create buttons properly. All right. So now we have that. And the good thing is we don't have to search the entire tree every time. We can search from the current context. So we can say if current context, just check the current context ID, right? First. So we just set that to be active and return it, but more likely than not, it's not going to be the current context. It's going to be one of the children of the current context. So context, child capacity. All right, so we're going to say children I, ID is equal to ID. Oh, we should probably check to see if it's actually valid still. That would be helpful, so we don't have any null pointer exceptions. All right, so if it's a valid child, then we check to see if the ID is an ID we're looking for. If it is, we set it to active and we return it. And that's that. And if it's not one of those children, we would want to, if it's valid, recursively check. You know what? Actually, we don't need to do that. If we're going to call, we could, yeah, so what we can do is we can just do return find set active ID. You see what I did there? I didn't even think about it, but this works well as a recursive call for itself because it's checking itself before returning. So that's cool. So that's neat because that'll do the recursive call down the tree and look for anything that matches the ID we're looking for, and then ultimately if we don't find it, it returns null, which means that it hasn't been added. So let's go through this, and the first time through in the debugger we should see that when we go to add the button, the node pointer should be null the first time through find set active, which it is, which is good. So we create it and we set up our data here. So if we look at the node and we look at, we've got our X and Y, we've got our width and height. We have, let's see, where's button data? There it is. And we've got our text width and height. So that's good. We've got, the text hasn't been copied over yet. And the ID is, oh, the ID isn't set. Well, that's not helpful. We should do that in here. And give the control node the tree root a crazy ID of a bunch of 9s, just so it's different. All right, so same thing. Node is null, and as we go through, node will now have an ID of 1 and all that other stuff. So then we add it to the current context. Current context has an array which has the one child, which is the button with the ID 1. So that's good. I also actually want to hit a breakpoint here for when we come back around for resetting the active state. So, okay, so, and this one for when we do a find and we actually find the child. Oh, wait, not there. There. Okay. So that all looks good. It should render, and let's see, why did that crash? ID is 2, current context is, that looked okay. Yeah, that's the root node. What's unhandled exception? Stack Overflow. Oh, because I'm not changing the current context. I'm going to change this a little bit. I didn't think about that part. I'm going to change it so that you have to pass what it is you want to search. That way it's a little bit easier to expand upon, because if we do it in current context, then we have to keep changing the current context, and that doesn't seem ideal. All right, so okay, this is our first time through. Node is null. This is our second time through. Oh no, this is the first time through still for button with ID 2. Node is null. All right, so now we're back at our begin call. We're gonna go to reset the tree. So if we look at our tree, the ID is all those 9s. The fact, because it's the root node, the active state is set to true. This has why are there no children? Is it still deleting the children? Yep. Okay, so that's still deleting the children. We want to change that. Oh, actually, you know what we can do? We don't even have to clear it out every time we just say active equals false. Then we don't have to do any search, because for anything that came through this part of the render, we're good, right? So the background renderer, is there background renderer? I don't remember. For the main tree, what does it do? Yeah, render background. You should be in the GUI namespace. All right, so render background, layer, node. Okay, we've got our width, height, all that stuff. It fills it with the color, the background color. So first time through, for that, so for the background, it's not going to set the active to false, which is what we wanted. So we don't need to do that recursive check. That's good. Let's try that again. Yeah, so begin doesn't really actually do anything except set the current context to the node that's passed in, which is fine. So this is a first time through for ID 1, first time through for ID 2, and null was node was null for both cases, for both IDs, I should say. I'm going to do this. All right, next time through. Now node. Oh, no, this is still the first time through. It's just I moved the breakpoint after here. So anyway, sorry for that being confusing. Okay, so now, all right, so now this is the first time through, but it didn't, interesting, it didn't actually find it. Wait, where did the, is it still, oh, I'm still clearing. Now I'm just leaking memory. Perfect. I didn't want to set that child entry in the array to be null. So again, first time through, this time for ID 1, ID 2. Excuse me. ID 1 and ID 2. Next time through, we found it. Okay, great. So we found it based on that ID. So we're going to set it to be active, which is excellent. That means we don't have to prune it out. So that's all looking pretty good. What? That's not looking good. Why is it adding more children to the capacity? Or why is it running out of capacity? We add the button, it finds it. Let me look at that a little bit closer. So first time through, it does press me and press me 2, and then the... Alright, so now it's got node. So it shouldn't... It's not initializing the control node, it's not adding it, so... Why... Where's that code where it's dealing add control node? It shouldn't be doing that at this point for the button. Add control node. What is it adding? What is this node that you're adding? Press me 2. That's weird. Why does it keep adding that back? Step through this a little bit more carefully. I was so sure that it was going to be straightforward that I seem to have made a mistake. Alright, so that creates the node and returns it. That's our text width and height. We're copying the text. We're setting the renderer. Then we're adding the control node, which is fine. It actually set that. And the node is set to active, right? No, it's not, but all right, we can we can fix that. That's not critical, but I want to do it now while I'm thinking about it so that it doesn't create a problem later. Okay, so let's go back into that. All right, so we didn't find it. We're going to go create the node. It's now set to be active. We've set the height and stuff for the renderer. We add the control node to the context, which just adds the child, which is fine. And then that's good. And then for this button, same deal. What is that? What does that mean? Run execute. Oh, I see. So we had that control node. Okay. Render. When it renders, it's going to find the child. It's going to call the renderer on the child. After it's done with its own, and then it's going to deactivate the control. Right, so by the time we exit out of here, we should have a parent with 2 inactive children. What's the shortcut code for that? Shift 11. All right, so if we look at current context, we should have 2 valid children in here. Let's do this. Current context children 0. Current context children 1. So that's ID 2. That's good. That's ID 1. And this should be, if I do children 2, this should be null, and that's garbage, so that's good. So we render it, we end the GUI, we do an update, we go back, we do it all over again. We're going to add the button, so we do the search. The button is not null, so we don't have to add a new one. We check the mouse. We return. We do the same check for button 2. It is, oh, it's null. Why is it null? If tree child find set active for tree ID. So it's going to check the root, set it to active. So it wouldn't be for the root of the tree. The first time through, well, let's, instead of me talking it through, let's actually see what it does. So right now there's nothing in the current context, so this is not all that interesting. You can remove some of these other breakpoints. Okay, so really? Where did button 2 go? How come button 2 didn't get added in to... That's weird. I don't care about that necessarily right now. I just want to see when I go to button 2. Oh, I see. So it was looking for it and we had the one child, right? Okay. And that goes in and it looks at the IDs and there are no children in here, so it's gonna exit out. Actually, I guess I can just run to that point instead of setting a breakpoint. So now we're back out of that call to find set active, which it didn't find it. So we returned. Oh. Right. So what we need is it was returning null, but we hadn't traversed all the children yet. So if temp return temp, otherwise it's got to keep going. That's why it's creating new ones, because every time we do a search, it's not finding the second tree. That was just a stupid mistake. Okay. Let me think about where I want to... Well, let's just step through this now. So what we should see is that we get 2 buttons here, and then the next time around we shouldn't see any new buttons added. Correct, and it shouldn't crash. Okay. So now the button presses are broken, but it's not crashing, so that's good. All right, so let's see what got broken here. Interesting that moving that out caused it to break. This code, main window MX buttons, and then button width and button height. Button width and button height are going into the width and height of the node, so that's correct. Was it using anything else? It was using, it had the X and Y. That didn't seem to break anything there. That was setting the node button data. That's all good. Let's see, render, where's the render button code? Text width and text height, it's getting that from there. That's the width and the height. Is that the problem? I don't know that that would be data button hover. That all looks okay. Let's see. for even getting breakpoints on that. No. So isn't there no mouse data? X, MX, MY, X. X and Y have a value. Button width. Oh. Why is button width? Why is that? Bizarre. Okay. Oh. Why is it? Whoa. Why did it return the tree? Why did it return the tree to this call? Okay, so what's happening is for some reason it's getting back the tree. That shouldn't be happening because it should be returning back. It should be, I mean, effectively tree is whatever node we're looking at in the main component tree, but it should be calling find set active. It should actually be setting that to active over here. No, it's setting that to active here if it's got the matching ID, and then it returned, oh, dummy. So it's returning current context, which was correct before, but not correct now because we're using tree instead of current context. Okay. So that should actually be, I think that'll be good now. Yeah, okay. All right, that wasn't so bad. Buttons are working. The hover is not. What? If button equals 1, if data hover. What madness is this? This can be a Boolean now. Hover. Oh, where it's not actually setting hover. Yes, it is. Okay. So hover, that is equal to true. So if I mouse over, it calls that breakpoint. So let's see, for that node, did it change the hover to want true? It did. Okay. Did I just mess up my colors? Oh no, it's just not returning. Right. Okay. Well, see, this is good. So it was never forcing the hover back to false. Because we're reusing the nodes now, it's saving some of the state from the previous run, so it never unhighlights. Right? Okay. There we go. That's better. So, cool. So we've got that working. Now we need to do the final thing, which is we need to check to see if the child is active. And if it's not, then we prune it and all of its sub-children, descendants. Let's see. Let me just call this prune tree child. So we're we're gonna remove all of the children of this child, and then we're going to free this child, and then we're going to change the children in the array to null to free up that slot, and then we're going to continue. So the reason, so I talked about potentially not doing allocations and just having a separate, we could even just use the active flag as it is and just have an array of nodes instead of an array of node pointers, but I'll leave it for now. We've made, I think, enough changes for now for this control node. So what we're going to do is we're going to what's the problem? What don't you like about this? Oh, not control code, control node. All right, so same thing as before. Free up the capacity. So we have that child. If it's not null, make that null. And the reason that we're doing it that way is because at the end of iterating through all of the children, call free on the node itself. So yeah, I mean, we could even just simplify this even further and say, so if node is null, we return. So we just iterate over all the children by calling prune tree on all of them and setting them all to null. Well, actually, we don't even need to do that because honestly, we're getting rid of the we're getting rid of that anyway. So the node itself. So nulling out the children would only be necessary if we were to keep it around using the active flag or something like that. So I'm going to take that out. We don't need that. So let's see. So if the child isn't active, we're going to prune the tree and free the child. Oh, we don't need to do that because it will have been freed by prune tree. We just need to set it null for this. Oh, this should be node, not child. I want to set that slot to be null because now for that node we can free up that space for another control. And okay, that's not broken, so that's exciting. And controls aren't just disappearing, that's also exciting. So let's do something where we have some sort of variable that represents whether or not a button should be on screen, and clicking the button actually makes the button disappear and changes the state, and we should see the control disappear from the tree. So we say button is visible equals true. If button is visible, we're going to do we'll change the Y to that, make me disappear. So if that button is pressed, we say button is visible is equal to false. And I want to hit a breakpoint there because I want to have us look at the state of the buttons in memory first, and then we'll loop through another render and make sure that that disappears from the the root context, the background context. All right, so that occurred, right? Button is visible. I'm going to change it to false. So if we go back to our watch here, we can see we have 3 buttons in here, right? There's the ID 3. If you look at the control type, oh, that's not being set right. But if we had set it right, it would actually say button, which is why I like using C++ enumerations in Visual Studio versus just a numeric ID. We'll fix that in a second. So now the next time around, we shouldn't hit this because the button shouldn't be visible anymore. And what we should see is that when we look at the child 2, it should have become null. It did not. Okay, well, let's see what went wrong. Well, the good news is it's not active, so that's at least something. Oh, you know what? Okay. That's fine. So what's going to happen is that it's going to be the next time around it's going to remove that, because this time around, no, sorry, on the render is when it's going to get removed. I jumped the gun. So, all right, so it should disappear now. Okay, good. It became null. And if we run that, the button disappears. So let's actually run that and see it disappear. Cool. All right. Any questions on that? We got some stuff done. While I'm waiting to see if anybody has any questions, I'm going to start creating a file for our code here. So I'm going to move these structs out and this. I want to make this a constant. This a constant 2. The renderer can be moved out here. This is all just kind of housekeeping stuff, right? Nothing super crazy. We're going to turn off. We don't want this to be compiled because we're including it in the main thing here. We have our enumeration and let's see. So all of this, add control node. All that could go into this GUI namespace, and the goal is I want to just kind of have all of this stuff that's related together in this one file. Probably rename that initialize control node to something a little bit more generic, but that's fine for now. What did I break? Control renderer. Oh, I moved this. I need to know what a control renderer is in order to define it. Oh, my constants, right. Okay. Main window. Yeah. Sedated Snail, have you watched Ferris Makes Emulators? No, I haven't. Is that a YouTube series? Okay, let's see. So we got that separated out. Might even want to just kind of further. I think I even want to kind of further isolate all of this stuff, because I'd ideally like for the application to just be about the application. So tree root, all that stuff can go there. I'm going to let's know where main window is, because I moved that into here, right? No? Oh, was it in the initialization stuff? I don't know where that went. That's weird. Okay. I don't know. I must have accidentally deleted it. I mean, I guess all of this stuff technically could go in that namespace, just to maybe the colors we can leave, but the rest of the stuff can go into that namespace just to keep it all nice and isolated from everything else. So yeah, that needs a semicolon. That's tree root, blah blah blah, and then I want to change begin. And we're just gonna say that, because why not? I mean, it's like all so it's all pretty self-contained that way. If we can just have it know where everything is, and it pretty much is kind of pretty much is self-contained. All right. So what happened? Did I? Okay, so this is GUI main window, and this too many arguments and function. What? Oh, because node is a function? Too many arguments in function call. Render. Oh. Okay, it does need to. That's why. Could have fooled me. Is it just placement? Render background. So all of this is just because I'm I move things around and the compiler doesn't know where the things are that I'm referring to. GUI button redefinition, previous. Oh, right. So this is. I thought I renamed that to render button. I did. Button. Did I copy it twice? No. Previous definition was enumerator. Oh. Right. We had this problem before. That's annoying. Right, we don't need to pass that anymore. Yes, okay, so that kind of all hopefully is not completely broken. When we add the new button, what we also should be doing is adding control type equals button. Yes, okay. Yeah, he makes N64 and Virtual Boy emulators. Oh, cool. I'll have to check that out. That sounds pretty interesting. All of that stuff is pretty fascinating to see how people build emulators. This is null. Current context is null. Not off to a good start here. Tree root. Well, oh, am I calling? Nope, I'm not. And we can even do this. We can pass it the screen so it sets the main window, since that's really only something that the GUI stuff is actually concerned with. Great. Okay. Let's try again. All right. Cool. All right, we're back and we have some organization here, and now this code is literally just all about the UI, right? It's setting up our window, it's saying the button is visible, it initializes the GUI with our screen, it handles the loop where we do our GUI begin and end, we render our buttons, we do the conditional button, we have the render statement, and then we do our update to the screen. I think we can probably get rid of this. I feel like, oh, actually, you know what? We'll rename render to end. Because that's really what we're saying, right? Is that at that point we're done and we want to render. And then we can even do this too, where we say, okay, we don't even have to pass this. Oh, I gotta get rid of that. Right. Cool. All right, so we've got buttons. Now, let's see. So the next thing we should be able to do is text labels. That should be relatively straightforward. One thing I just wanted to show was the thing that I was talking about before, where when you have a, if you're not familiar with Visual C++ or Visual Studio and C++, I should say, of course it's not doing what I want it to do. It doesn't have the control type. Why? It should have it. I told it to set it. I thought. Create the button. Control type is button, which is 1. Well, that's disappointing. What did I miss? So here's the node. The control type is set to 1, which is button. And then, yeah. And next time around, that is... Okay, yeah, no, those are the other variables which haven't been initialized. Oh, it is set to 1. Okay, that's what I was just going to show, is that the control type actually reflects in text the value when it's in enum, which is nice. It makes it easier than trying to remember all the different values that mean something as just a constant. All right, so let's add labels, because that should be easy, he says. Like I've said about everything else, right? So we'll call this label. And this should be relatively the same as with button. We don't need to return anything because labels don't return. I mean, I guess you could click on a label, but I don't know that we would ever need it. I don't know. We'll support it. Same thing as we do with the button. In fact, let's see. Probably a bunch of this is going to be the same in the end. The main difference is going to be that we're not going to be doing anything with the we don't need a button width and height like we do. Yeah, I mean, I guess it's essentially going to be roughly the same. The only thing is we're not going to be doing the... I keep saying that and then thinking about how that we are going to do that. The only thing we aren't going to do is we're not going to support changes for highlighting and clicking of the colors. It's going to be... So let's do this. So this is a label. Button data is no longer relevant to this, so we want to call this label data, which is essentially going to be similar to button data. Because I guess we want to know... I wonder if we're going to see these all being the same and then we just move these into the control. Probably. Let's do that. Let's move the button into, and the hover into the main control node, because realistically that's going to be common. The text width and height probably is common too. No, that's not true. Depends on the control. Okay, so for labels that's true, and for buttons that's true. All right, so that's that, and then we have we gotta call it label data, and now we gotta fix all the things we broke by making those changes. So this would be on the node now, because we moved that all out. Oh. Same thing with the button. Right, so let's see. Oh, that's just an extraneous period. Okay, so that's not too bad. So for the label, we have our buttons. generally not checking if labels are clicked, but I guess you could. I don't want to keep it out just in case we decide we need it, and then we have to add it back later. This should be label data. Let's see, what else? This should be label data. For labels, I could see us adding some specific data like the font we would be wanting to use potentially. You know, since labels tend to be a little bit more fancy than just a standard button in terms of fonts and sizes and stuff like that. So, all right, and then, well, render label, and then what is the syntax? What is the? It takes a layer and the control node. So. Oh, that's what we need to change also, because it probably is passing render button. Yeah, this should be render label now. And then I'm not going to draw a back. Oh, well, see, now that's something we might want to add to labels that are different. We want to probably add, if it's transparent background. So we have a background color, but we may not want to use it for labels. Typically they don't, but every once in a while you might want to do that. So let's make that an option. So bool transparent equals false. No, make it true by default. And node label data transparent equals true transparent. And then what we do is in here, we say, okay, if label data is, that's not transparent, then we're going to render our, come on, we're going to render our rectangle. So fill rect, no, trigger fill layer. Node X, node Y, node width, node height, node background, right? Are we setting the background anywhere here? No, we're not. So t-pixel background. Oh, not a pointer. Background equals white. Oh, we're passing that as, okay, so there. Now we can actually pass it if we want it to be something besides white. Okay, so we've filled, if it's not transparent, then we're filling the background the way we want to, and then we're going to actually draw the text, and same formula as here, so I'm just going to steal it. The only difference being that it's node label data text, and I had aliased all of this stuff here, so oh well, I'll just do the same thing. Well, I don't need to reference the, okay, do this for those guys, but okay. So who knows if that works exactly right, but let's give it a try. For the labels, They do still need to have unique identifiers because that's how we're going to know whether or not we need to keep drawing them. So this is going to get tedious. We'll have to see if there's a better way of handling this. Maybe we have some sort of ID auto increment or something like that, which wouldn't be perfect, but it would be potentially good enough for what we're doing to be pretty pretty performant. This is a button, we'll say, and we're going to leave it transparent to start off with. And you know what? I don't care if the button is pressed or not on it. I just want to see a label render. Okay, so what did I miss? 190. Why? I think it's my. So I think what it is my resizing code. I was thinking about that the other day, and I was like, you know, doing 50% resizing is kind of not. It doesn't actually seem like a good idea. We'd probably want a fixed padding or something like that. Well, that's totally banana cakes. All right. That wasn't even close. Where? If it's not node X, node Y, width, height, background. So what is this doing? I can just reference X and Y here. Move all of this over here, that's fine. Width and height and background. Well, yeah, so that's the text. That's, oh, this should be label data. Okay, that's better. So it was the using the button data there that messed it up. So let's talk about that for a second. So if you're not familiar with unions and how they work, basically these two structures coexist in memory at the same location. So if I have a structure like this in memory, normally you have your members like this, right? So we have button and hover and renderer, right? And all that stuff. And we get to this point where we have now this union here, and it's anonymous union in C++. Basically what it's saying is there is this chunk of memory that that the compiler allocates, and it's big enough to hold either button data or label data. It'll hold either one, depending on what which one you. It'll hold either one, period. But what you actually access is up to your code. So when we go in and we access button data and we look at text width, that's the first value, this integer. It was problematic because we don't have text width as the first member of our label data. It's actually the transparent Boolean. So there was a misalignment there, and that's why it was getting sort of a crazy behavior. So something to keep in mind where unions are useful, but if you, like so many things in C and C++, if you mess it up, it is very unforgiving sometimes, and you get weird behaviors. All right, so we've got a label, we've got a button, and the label has a background color. I'm going to change this back to being transparent. Now we have a label with a button and the button that disappears. Cool. So that's good. So, I mean, we're halfway done, right? So at this point, where are we? 10:34. Are there any questions on anything else that we've done so far and how this is all shaping up? I mean, what I think where we're at this point is that we're going to just be building out controls. The other piece of this is we've got to build out the functionality that actually looks at the file system and handles stuff that interfaces with the operating system. And I'd like to do that in a way where it is not dependent, or where this code is not impacted by that. That there's just code that runs that gives us the list of files and stuff like that. Like I had said, I'd like for it to be sort of similar to Sublime Text, where when you have it open, if you drag a folder into it, it gives you the entire listing of that folder. I'd like for that to sort of be the default behavior for whatever folder you're in. It will just open up the files in that folder and the folder listing, so that it essentially treats that folder as a project, just to keep project management simple. I don't really necessarily want to be dealing with any sort of complex project files to manage metadata about the files themselves, which will have data in them. So I think I'm gonna call it a night early today. You know, in a certain sense, we didn't really finish a lot, but at the same point, I'm kind of running out of steam right now. And also, we've got, you know, all of this stuff kind of moved out. If there's one more control we could do a simple one, and kind of wrap it up there. So, let's see, we've got labels and buttons. We could do maybe just a simple grouping control, which is just a rectangle frame around. I don't know that we'll use that. I mean, you know, I've talked about it before, but the sort of layout that I'm thinking is we'll have our list of files here, and I don't want to start a file list today right now, just because it's pretty complicated. It involves things like scrolling, but you'll have your list of files here. You'll have your active work area over here where you're doing whatever you're doing, and there are going to potentially be buttons and like a palette there or here. Not sure which side I want it on. And then do we need a menu system at the top? I don't know. We can do, we can do the grouping, and then I'll call it a night for now. So call this a frame, because it's just going to frame the the stuff around it. So there's text. Are most controls going to have text? Most controls are probably going to have text. The question is, do we care about the text in all cases or not? Let me not refactor that right now, because I'm just going to get too far into that. So frame data, we can hit that next week. So it is going to be similar to this. I'm trying to think if we want to deal with so we need the text width and height. We also probably want some sort of padding around the text. I think that's probably how we're going to end up handling all of the all of the structures. We're going to add padding to it, similar to if you've worked in HTML, you can add padding. So we'll add that there. We'll just make the frame data actually deal with that properly right now. So we have the width of the frame itself. We have the height of the frame itself. We have the text width and the text height. But we also need to know the text. So when you have a frame like what I'm describing, where it's just a simple line, a rectangle, right? And then you're going to have this little notch, and you have some text, right? That's pretty simple to draw, but you still need to know what the size of this around the text needs to be. That would be the padding. All right, so it's kind of shaping up that these are all roughly similar, but again, I don't want to get sidetracked with refactoring things, and then we're going to just do nothing but refactoring. So I'm not going to track clicks on the frame right now, just because I don't really care about that. I don't think we're going to ever use that. Labels, like I said, I could see where we might want to do that, but so that's not going to return anything. It's going to take an ID. It's going to take an X and a Y. It's going to take the text that we're going to display at the top of the frame, and then we also should pass it a width and a height. And then let's see, so we need to, whoops, we do need to check to see if it's there already. All right, so if it's not there, then we're going to create it. And that's really all we have to do at that point. We don't care about any button states or anything like that. So just trying to remember. Okay, so we're going to initialize that, and then we're going to add our control node to the context. We haven't touched current context at all yet in terms of how that applies. Actually this might be the place that we do that, because the frame would have the controls contained within. Let's call this frame begin. And then we're going to pop the current context, but we'll worry about that in a second. I'm not going to mess with that yet. So, all right. So, we can say the background is just going to be white, because it's not going to have a background color. It's just a frame. The width is the width, and the height is the height. And then the node frame. Let's see. Did I not add frame data to the union? Okay. So frame data, that's just us copying the text over. So that's good. And then the text height and width, we can calculate that. Yeah, so That's this Tigger text height T font text. So that's our text height and width. Then we have the padding that we will apply. Let's just put that in. We'll say the padding is 5 pixels. And let's see, so we have our height width. It's going to have the main width and height set. We need to set our renderer. What did I call this? Render frame. Just want to keep the naming consistent. Okay, so we've got that. So that should be all that we need. If it doesn't exist somewhere, then we need to create it and add it and set all that stuff. And then in the render call, we say it's just Tigger rect to start off with. Layer, node X, node Y, node width, node height. And then the color is black. And then we want to render the little notch for the text. So let's see, the text height will come in handy there. So we want to say, okay, the notch height is node frame data text height plus padding times 2. Right, so that's the right, yeah. So the padding, because the padding applies to the top and the bottom, and the same thing with the notch width. Okay, so now we've got our width and height for our padding, for the notch that we're drawing. And then we want to draw that. We're going to do that as a fill. And we're going to use whatever the current context's background color is. So layer, and then let's see. So let's say no, the X. Let's say 10. I don't know. That's just kind of an arbitrary number. The Y is not going to be arbitrary. That's the notch height divided by 2, right? Because we want to offset by half the notch height to fill in and accommodate whatever text we're going to be putting there. And then it's notch width, notch height. And then, so like I said, the background color is current context background. And then we're going to draw our text. And so this is node X10 plus that's just plus padding, I guess. Plus padding. And then this is, we want to center this on the line. So it's the node Y minus half the text height. So node frame data text height divided by 2. Oh, I forgot to put the font in, so that's basically a parameter key font. And then the color, which can be black, and then the text, which is the node frame data text. Who knows if that's going to work right? Oh, yeah. So that's our padding, and then, yeah, so now we can draw a frame. So, okay, before we do that, so when we do the frame begin, we add the control node to current context, but then we want to change current context to actually be the control node. And then, or actually, I think we should do something like push context node, and then pop context. So current context is just a pointer. Yeah. Well, we don't actually have a stack to do this, so I'm gonna cheat for now because I don't really feel like implementing a stack at the moment. And we're gonna make a one level deep stack, which is totally cheating, but like I said, I don't care right now. I just want to make this work. And so if stack, if not stack, stack equals current context equals node, current context equals stack. We'll do that if stack, if not stack, no, if stack. Yeah, if not stack, then return otherwise. All right, so again, I understand that that's totally cheating and not actually a stack, but it is for the situation that we have right now, where we have only one push and pop that we're going to be doing for the purposes of this test. So we can fix that when we come back next time. So let's do this at 10. 10, 500, 500. This is a frame. And then we're going to say GUI frame end. And watch this. Oh, okay. Well, that is close to what I was aiming for, so I'll take that. What is with the text though? Text isn't working, so let's take a look at the frame renderer and see if I'm like missing the text or something. Is the text no good? Yeah, the text is no good. What did I break? Truncate text. Oh, same problem as before. See, this is what happens when you copy paste. Frame data. All right. So actually, that text looks crappy because of the shadow in that font. So we'll say it's dark gray. Yeah. I'm reasonably happy with that. That's actually better than I expected it to be. And again, I know this is all super basic stuff, but we're kind of building the foundation for the other controls. The important thing with this is to understand that we can look at this in the code, that the controls. So this is kind of cool because we're actually now taking advantage of the fact that we have this tree structure a little bit more. The controls for the buttons should be showing up in the frame children, not the main child of the root. So we say GUI tree, or was it root node? well, let's start with this. So we know that the ID should be all 9s. That, okay, yeah, so children 0. And then if we look at children 1, that should be null, and it is. And so the reason it's null is because when we push the frame onto the fake stack that we have, it then takes over the current context, which then means that it assumes any child controls that get created. So that's kind of cool because, again, that's the whole point of why we built this tree structure, right? Is that what we're actually seeing is now we've got the background, which is 9, 9, 9, 9, 9. We've got one node, which is our frame. And then we have our label and our 3 buttons, right? And we're traversing that whole tree structure to then compose the fully functioning user interface that allows us to click on buttons. Where is that? We can click on our buttons and make that button disappear. And we could even potentially make that whole frame disappear. Why don't we do that? Why don't we make the whole frame disappear and see if anything crashes? Let's change this to frame is visible, and instead of it applying to that button, let's make that apply to the whole frame. Right? And that'll be cool because then the whole thing should disappear, and we should be able to inspect memory and see that. Yep, so the whole thing's gone, and now if we stop at the current context, we should see that, yeah, so the children are gone. So now if I were to go in and manipulate the frame is visible and add it back, it should bring back that whole frame. Yeah, so all that's working, and then bam, frame is gone. So that's pretty cool. That's working the way that I wanted it to, and we can go on to add things like floating windows and other stuff in the next stream, because that's we're at a pretty good spot, I think. Any questions on this? I know we haven't been doing a lot of actual NES programming, but you know, working on the tools and getting that right is important, so that once we get back to the NES code, I'm hoping that we can get something by next week. Not next week, by Thursday, where we can actually take a PNG and export it into the char format for the NES, so that we can import the graphics into the game from the tool, directly from the tool. So that'll be I think that's the goal for Thursday. I may have to cheat and work on a little bit of the controls for this. You can let me know in the comments on the video on YouTube, or in the chat if you are okay with that or not. But I think it might be necessary just to kind of move us along back to the assembler code, and you know, unless people are like super interested in the way that these controls get rendered, I'm not sure that it's vitally important to NES programming to see how I'm going to be drawing these. So let me know if there are no more questions, or maybe there are. I don't know. I'll wrap this up for tonight. All right, well, it doesn't seem like anybody has any questions, so I will see you next time. And like I said, if you have a strong opinion either way, let me know on the recording on YouTube if you want to see me build these controls on stream, or if not, I'll build them I'll build them on all my spare time, and this way we can get back to NES coding. All right. Thanks for watching.